Hi everyone, this is Dr. P. Sai Prasad, Associate Professor, Department of Computer Science and Design, St. Martin's Engineering College. Now I am going to discuss an important topic, Introduction to Data Structures. So coming to the contents, Introduction to Data Structure. What is data structure? Types of data structure, linear data structure, non-linear data structure, difference between linear and non-linear data structure, operation on data structure, tree traversal. Now coming to the introduction to data structure. So nowadays we know that data means information, structure means a unit. So a collection of information handled as a single unit is called data structure. So a computer is an electronic machine which is used for data processing and manipulation. So to do all these tasks we need data structure. Now what is data structure? So a data structure is a specialized format for organizing, processing, retrieving and storing data. So in computer programming, data structure may be selected or designed to store data for the purpose of working on it with various algorithms. So here there are two types of data structures, linear data structure and nonlinear data structure. Coming to the categories of linear and nonlinear data structure, linear data structure again classified into two types, static data structure and dynamic data structure. So static data structure, example data structure is array, dynamic data structure, queues, stacks and linked lists. So coming to the nonlinear data structure, there are examples are trees and graphs. Now we will see one by one. First coming to the linear data structure. So what is linear data structure? So linear data structure means those are the data structures where the data elements are stored in a sequence. So as we already said in the previous slide, the examples for linear data structure are queues, stacks and linked lists. So coming to the queue, first we will discuss about the stack. So stack, it is a data structure in which operations are performed at only one end called top of the stack. In the insertion operation is referred to as push operation and deletion operation is called as pop operation in stack. So stack is also called as last in first out or first in last out data structure. Because here if we consider the stack, if there are 5 elements 1, 2, 3, 4, 5. So if I want to insert or delete any element, we will perform only at one end called top of the stack. So the initially that stack will be null. So then coming to the queue data structure. So the data structure which permits the insertion at one end and deletion at another end is in queue data structure. So the insertion operation will be performed in rear end and the deletion operation in a queue is performed in front end. So queue is also called as first in first out data structure or LILO data structure, means last in last out data structure. So coming to the elements in the queue, so we are placing the elements one by one in a sequence manner. Suppose we will take the 5 elements like this. So here we will keep the elements in a queue. So like this 1, 2, 3, 4, 5. So if we want to delete any operation, we will perform the operation at the deletion operation at the front end. So want to delete the insertion operation, perform the insertion, then we will perform the insertion operation at the front end. So here in the queue, the insertion operation is also called as NQ operation. The deletion operation is also called as DQ operation. So next coming to the nonlinear data structure. So nonlinear data structures are those data structures where data items are not arranged in a sequence. Coming to the examples of nonlinear data structures, trees and graphs. So coming to the what is a tree and what is a graph. So coming to the tree, so a tree can be defined as a data items which consists nodes. All nodes are the arranged in branches and sub branches. So a tree consists of nodes connected by edges. So in the tree, each node is represented by a circle. So each circle, two nodes are connected by the edges. So the top level node we are calling in a tree is root node. The bottom level nodes are leaf nodes. The middle all other nodes except root node and leaf node are called internal nodes. Then coming to the graph. So graph is a collection of nodes and edges. So a tree can be viewed as a restricted graph. So here graphs are having many types. So simple graph, subgraph, multigraph, mixed graph, weighted graph, unweighted graph, directed graph, undirected graph, like that. So here for example we will take the graph with 5 vertices A, B, C, D, E and E. Here the vertices are represented by a circle where the edges are represented by the lines, straight lines. So here each vertex is having its own data. So edges here connected between the nodes. If we represent the edge with the arrow mark, then that graph is called directed graph, else it is undirected graph. So coming to the multiple graph means if there are more than one edge between the same set of vertices, then we are calling multiple graph. Then coming to the difference between linear and non-linear data structure. So coming to the linear data structure, as we said earlier, every item is related to its previous and next item. So coming to the non-linear data structure, every item is attached with many other items. So data is arranged in a linear sequence. In non-linear data structure, data is not arranged in a sequence. So here coming to the linear data structure, data items can be traversed in a single run. Here data cannot be traversed in a single run. So example, array, stacks, queues and linked lists. So here non-linear data structure examples are trees and graphs. So next coming to the implementation part, in linear data structure implementation is very easy, but coming to the non-linear data structure implementation is very difficult. Next coming to the operations performed on data structures, there are the 9 types of common operations are there. So one is creation of a data structure. So the coming to the next operation will be destroy. So next one selection, next searching operation, next updation, traversing, merging, splitting, and then traversing of all the nodes in a tree or a graph. So now we will coming to the tree traversal. So tree traversal is used to traverse all the data which is stored in the tree data structure. So coming to the tree traversal definition, tree traversal refers to the visiting of the all vertices one after the other. So tree traversal techniques are 2 types. So one is depth first search traversal, second one is breadth first search traversal. Coming to the depth first search traversal, there are 3 types of depth first search traversal techniques. One is pre-order, second one is in-order, and third one is post-order. Then coming to the breadth first search technique, it is also called as level by level order technique. Now we will see one by one in depth how to perform these tree order traversal techniques. First coming to the depth first traversal techniques. So depth first search traversal techniques fall under 3 types. First one pre-order traversal, in-order traversal and post-order traversal. So now coming to the algorithm of pre-order traversal. So coming to the algorithm of pre-order traversal, yes, now coming to the pre-order traversal. So if you take pre-order traversal, pre-order traversal, if you take a tree like which consists the data elements which are A, B, C and D and thereafter E. So now if we want to traverse all these 5 nodes in as per the pre-ordered traversal, first we will traverse the root node and then left child followed by the right child. So now coming to the root node. So here in this tree, the root node will be A. So after that, coming to the left sub branch, once again call the pre-order visiting or pre-order function. So in this root node will be B. So after that, coming to the again left sub branch, in this left sub branch again root node will be D. So now all left sub branch nodes are over. So coming to the right sub branch, the only one node available, that is C. So this is how to traverse the all nodes of a tree according to the pre-order traversal. Then coming to the next one. So the next traversal technique will be in-order traversal. So in-order traversal, the visiting order will be left child, root node and right child. So if we take a tree with 8 nodes, so A, B, C, then followed by B consists of 2 childs, D, E, then F, G, and D consists H. So now in this tree, if we apply in-order traversal, then the visiting order will be left child, then followed by root node, followed by the right child. So first coming to the root node. So here again it goes to the left sub branch. In the left sub branch, once again it will visit the left sub branch. So in this left sub branch, again it will print the leftmost node, that is here H. So after H, it goes to the root node, it will print the root node D. So after that, it will print the node right child, but it does not have any right child, so it goes to the root node, that is B. So after that comes down and it will print the right child of the B, so that is D. So after that, finally the root node of the entire tree will be A. So now A. After that, now coming to the right sub branch, in the right sub branch the root node will be here C. So in that the left node will be F, followed by the rightmost child G. So now this is the in-order traversal technique in the tree traversal. Now if we go to the third technique, that is post-order traversal technique. So post-order traversal post-order traversal. So in post-order traversal, if we take any tree with the 5 elements, A, B, C and D followed by E, and now if you want to insert any element in the tree, we will add as a left child to the C, say for example F, and right child will be G. Now coming to the post order, the visiting order will be left child, right child, followed by the root node. So left child, right child, followed by the root node. So according to this visiting order, the first node will be the left sub branch BDE. In the BDE, again B is the root node. The leftmost child will be the D. So D will be visit first. So after that, it goes up and the root node will be here B. So, but the visiting order will be right child. So next it will print E. So after E, it print the B. So now the left sub branch nodes all are over. Then as per the visiting order of the post order traversal, the right child only will be available. So coming to the right sub branch, in the right sub branch, again in the left child will be F. So then it will traverse the right child. So that is G. So next after that it will print the next node C. So now left sub branch nodes are over, right sub branch nodes are over, only the left node will be the root node. So which is A. So now according to the post order traversal, the visiting order of this tree will be D, E, B, F, G, C and A. So these are all called comes under depth first search traversal techniques. So next coming to the second category of the tree traversal technique, that is breadth first search traversal. So the breadth first search traversal is also called as level by level traversal. So breadth first search traversal prints all the nodes of the tree level by level. So for example, if we take the tree with vertices, so breadth first search traversal, if you take a tree like A, B, C, so D, so here A consists of 3 children. Similarly, next to B, again B consists of E, F, G. So C consists of 2 more childs, H and I. So then D consists of only 1 child, for example. So for example, it is X. Now coming to the tree, in the breadth first search, we will represent the levels. So this is comes under level 1. Next, these 3 nodes comes under level 2. So next, all the leaf nodes are level 3. So level 3. Now, if we want to implement the breadth first search traversal on this tree, it will print all the nodes of the tree level by level. So first it will print the level 1 nodes starting from left to right. So the level 1 nodes from left to right will be the first one is only one node, that is A. Then coming to the level 2, so here in this example level 2 consists of 3 nodes. In these 3 nodes again starting from left to right. So the left to right will be B, C and D. Then followed by the next level, level 3. So in this level 3, the nodes visiting order will be from left to right. So that is E, F, G, H, I, X. So finally, the breadth first search traversal to the given tree are A, B, C, D, E, F, G, H, I and X. So now finally what we will conclude is here regarding tree traversals. So if for example if we take a unique tree to the all tree traversal techniques, so like this. So A, B, C, here D is there. So next child will be E. So C, child will be F. So the right child will be G. Then followed by the H, I. Then the children's to the E will be J and K. Now we want to implement the tree traversal techniques all 4 types. Coming to the pre-order traversal, so coming to the pre-order traversal, so the visiting order will be left, root and right. So now coming to the left sub branch, in the left sub branch again here the leftmost child will be H. So after that the root node will be D. So the right child to the D will be I. Then now all left nodes are over. Then coming to the root node B. Root node B. Next followed by the all right nodes. In the right nodes again left node, that is J. So after that root node will be E. So K. So now all left sub branch nodes are visited. Then as per the visiting order, then root node will be A. So then coming to the right sub branch, in the right sub branch again the visiting order will be left child. So F comes first. So after that C, then followed by the G. So now this is how to traverse the tree as per the pre-order traversal. Then coming to the post-order traversal. So post-order traversal, the visiting order in the post-order traversal will be, so now we will see the post-order traversal. So the visiting order will be left child, right child and root node. So now coming to the left sub branch, here first left child, again here in the left sub branch H is the leftmost child. So after that right child, that is I. So then followed by the root node is D. So then left nodes are over. Then coming to the right sub branch, all nodes. So as per the visiting order of post order traversal, first node is J. So then coming to the right child of the sub branch K, followed by the root node E. Then now finally the root node becomes B. Now coming to the right sub branch nodes C. So left sub child will be F, then right child will be G, followed by C, at the end A. So now this is the visiting order according to the post order traversal. Then coming to the in order traversal. So in order traversal, according to in order traversal, the visiting order will be left child, root, right child. So now we will take the tree with the nodes A, B, C, D, and the children of B will be E, F. Now according to the visiting order of the in order, the traveling will be starts from the left child. First coming to the left sub branch. In this left sub branch again it will visit the left child, that is E. So after that the root node of the sub branch will be B, then followed by the child F. So now all left sub branch nodes are over. So according to this, after completion of left child, it will print the root node, that is A. So followed by the right child, so that is D. So then coming to the finally breadth first search traversal. So breadth first search traversal is also called as level by level traversal. So according to the breadth first search traversal, the all nodes are visited level by level. So for example, if we take the tree which consists more than 2 nodes, so EF, see like this. So now first we will divide the tree into levels. So this is level 1, next level 2, followed by level 3. Now as per the breadth first search traversal, it will print the nodes A, then followed by the level 2 nodes B, C, D, followed by the nodes in the level 3. So that is E, F and G. So now this is as per the breadth first search traversal. Now, so I will demonstrate all these types of traversal with the So what is data structure? Explain different classification of data structures. Already up to now we have seen that the different types of data structures. Data structures are two types: linear, non-linear data structures. Again, classification of data structures. Linear data structures are two types: static and dynamic data structures. So static data structures are arrays. Dynamic data structures are stacks and queues. Coming to the nonlinear data structures, tree and graphs. So here if we see this one, data and information. So what is data? So data means it is refers to the value that are unorganized. But coming to the information, so information is a well structured format. So what the data structure definition exactly is? The data structure is a specialized format for storing, organizing, processing and retrieving the data. So now coming to the linear data structures are form a linear sequence, whereas non-linear data structure does not form a linear sequence. So implementation of linear sequence will be very easy, as well as implementation of non-linear data structures are very complex. So nowadays data will be very big data. So to arrange all this big data, we should use the data structure. So maintaining the data is very big problem nowadays. So that's why there are several techniques will be available. They are big data analytics techniques. So then coming to the our PPT. So here in this diagram, we can easily identify the categories of data structure. So linear, non-linear, linear again static dynamic, array, queue, stack, tree, graph, linked list. Then coming to the last one. So this is also the categories of tree traversals. This is the image here we can find. So pre-order, in order, post order, breadth first search traversal. So followed by the breadth first search traversal example. This is a tree. So level order traversal will be level by level A, B, C, D, E, F, G. So thank you everyone.